This is GMATS 41. You are welcome to our ordinary differential equation class. In this video, we now want to start with the first form of ordinary differential equation known as the separable variable equation. It's very important for you to be able to identify a particular form of ordinary differential equation so that you know the technique to apply in solving it. Now, how do we identify the general separable variable equation? Now look at it written on the board here. This is how the equation usually appears, alright? Now identify your differential coefficient dx. I call it parent. Differential coefficient dy, I also call it parent. This will be controlling x variable, this will be controlling y variable. Now, however, in separable variable equation, you have function of x multiplying a function of y. And then function of x also multiplying what? Function of y. That is the form in which separable variable equation generally takes. Although there are still special form of it, but in terms of, in general, this is how they usually appear. Where function of x and y are being multiplied. Now what do? You're going to find a way to separate them. Okay? Since they are being multiplied, to separate, you have to divide by something. For example, coming here. Alright, now after transferring this function to the right hand side, you have this. You see, this sign can either be plus or minus. Once it crosses, alright, it will change sign. That's why I have minus or plus, as the case might be when the problem is given to you. After crossing this, now how do I separate the variable? Like I said, you identify your parent here, this is the x. So this g2y will be removed because it's a function of y. It shouldn't go with the parent dx. Then here, this is the parent dy, the differential coefficient. So you should carry only y variable. It therefore means that your f2x here, this f2x, has to be what? Removed. So the question is, how do we remove your g2y from here, and how do we remove f2x from here? Mathematically, because there is multiplication between these two functions, function of x and function of y, to remove this g2y, you have to divide. Which means you divide here by what? By g2y to remove this y variable. And then come over here, divide here by what? f2x to remove this x variable from the parent dy, from this differential coefficient dy. Now, did you take note that in all, what I did was to divide by what? f2x, I used it to divide, and then what? g2y, I used it to divide. Now, if I put 1 on top, you know, if you're dividing something by another thing, it's the same as 1 over that another thing times the something. Look at it. A divided by b is the same as 1 over b then times a. Does that make sense? So all in all, what you do to this equation is simply to use 1 over f2x g2y. That is a function of x that you need to remove from y, and a function of y that you need to remove from x. 1 over their multiplication. Use it to multiply each of the terms. That's what you have here. Now, why I had to write it out like this is there is a name we give to this. We call it integrating factor. We call it what? Integrating factor of separable variable equation. So take note of that. You have to put it down, okay? Now, once you do that, what is going to happen? This g2y will cancel this g2y so that f1x over f2x will be left. Then you come here, this f2x over f2x will cancel so that g1y over g2y will be left with their parent. And that's what you have here. Once you've separated, the next thing is to integrate. And that's why you have your integration sign here. Just look at it and then ask yourself which technique of integration will apply depending on the problem that you are solving. So, we are done with explaining how to identify a separable variable equation and how to separate using integrating what? Factor. Please don't go cramming this, memorizing it, no. Once a problem is given to you, you will definitely know which one is the f2x and which one is the g2y, right? In the next video, we're going to pick problems, questions to solve, and then it will even become much more clearer. We have this question on the board, so let us solve that. We have to solve the equation. Look at the equation. Okay, so this is the differential equation. Then we have options provided. So we're going to solve towards that option. Now let's move on to bracket y plus 3dx equal to, let's transfer the xy term to the other side, that's the dy term. Alright. So at this point, you notice that we can do our separation. The differential coefficient controlling here is the x, so you remove this y plus 3. The differential coefficient here is the y, so you remove this x term from there by separating your variables. So let's do that. We'll be left with 2. This x will come under dx equal to, we'll be left with y. This y over 3 will go under, and they have dy. So we've separated. We can now do our word integration. Introduce integral sign. So this term here, if you integrate it, you know it's the same as bring out the constant 2, then integral 1 over x dx. If you differentiate the denominator, you will get the numerator 1. Therefore, the result here is 2 ln of the denominator. 2 ln x equal to, now look at the right hand side. To integrate it, we are going to use polynomial division first. Why? Listen to this as I state the case 1. Subsequently, we'll still see the other second case where we still need to use polynomial division. Now, did you notice that the numerator polynomial term there, the degree, that is the power, is equal to the power of the denominator polynomial term? Look at it, this y raised to power 1. This y raised to power 1. They have equal degrees. You have to integrate. Now, the integration, a technique tells you to use polynomial division first before integrating. If the degree of numerator and denominator are equal. That is one case. We might still meet the second case subsequently. Is that okay? So let us quickly focus on this. We are going to divide this y by y plus 3. You would recall in your polynomial division, you already may have learned something like this, where you divide this term by the divisor. Isn't long division, right? But I'm going to use the Omakase short division procedure so we can quickly get our result here. Now let us do that. This y on top divided by this y here, what are you going to get? So you're going to get 1. That 1 is the quotient. What do you do with the quotient? Use the quotient to multiply any term in the denominator here that did not take part in the division. If you notice, you didn't use this 3 to divide it in the numerator, alright? So it's going to be 1 times 3, which will give us this plus 3 here. Change that sign of plus 3. If you change the sign of plus 3, you get minus 3. Then add that minus 3 to its like term in the numerator. The like term of minus 3 in the numerator is 0. Because there's no constant term in the numerator. So let me ask you now, minus 3 plus 0, or simply 0 minus 3, what will you get? You will get the remainder to be minus 3. To be divided by the divisor still, that is the denominator. You have finished your division here, because if you notice the remainder you had here, y in this remainder is y raised to power 0. The power of that y here is less than the power of y in the denominator, so you stop. How did I know that the y here is y raised to power 0? That 3 is the same as 3 y raised to power 0. Y raised to power 0 is 1. 1 times 3 still give you 3, so you've not changed anything. The power of y here is 0. The power of y in the denominator is 1. So at this point, you have finished your division, since the power in our final remainder is less than the power in the denominator. Alright, so I'm going to put dy. So we now have 2 ln x equal to, this will give you, use the integral and dy to open up the brackets, integral 1 dy. If you do that, you're going to get y. Once again, we've done something like that. It will welcome back the variable. Then next, minus integral 3 y plus 3 dy. That is integral 3 over y plus 3 dy. If you want to integrate that, that 3 will come out. You know that as a constant. So you'll be left with 1 over y plus 3 dy. Once again, differentiate this denominator, you will see that you will get the numerator. Therefore, our result is minus 3 ln of the denominator. I'm going to put a constant of integration now. Because this x term has a ln, I will introduce ln to the constant of integration. Now, this is the first general solution we obtained by solving this. Compared to the options A to D, I mean to E you have here, is there any one that is the same as this? I doubt. But first of all, you look at this ln term. Option A has ln, option C has ln. Quickly compare those answers or those options with your answer here. You notice that it's not equal to any one of option A and C. Therefore, you're going to find a way to simplify this general result to see if you can get this option B or D as your result. We are going to take a short break. When we come back, we'll simplify this term. We want to simplify the general solution we obtained here, since we didn't get any option directly as the answer to this problem based on what we obtained here. So in simplifying, what do? I just look at this. I will collect all the terms that has ln to both sides. Is that okay? And so all these terms here will be moved. Let me move them to the left, this, because they both have lane. And so this will give us 2 lane x plus 3 lane y plus 3, and then plus lane c, and that will be equal to y if you work on that. So you notice that here we can use some laws of logarithm like lane x squared plus lane y plus 3 cubed plus lane c equal to y. I apply prior law of logarithm here. And so we can now apply addition law of logarithm where you pick one of the lane, then multiply the numbers. You have c times x squared, then times y plus 3 all cubed equal to y. At this point, what do you think you do? Okay, if you look at this, is it equal to any option here? It looks like option A, but if you see, it's not option A. It's not, because in the option A, you have raised to power 1 over 3 here. There is no raised to power 1 over 3. So we're going to work on this again. Remove lane from both sides, and to remove lane from the left-hand side. To do that, you take exponential. So exponential of this term would remove this lane. So you have cx squared y plus 3 all raised to power 3 equal to exponential of this term. So this is the simplified term. I think let's see if it goes with any option. Okay, do you see that in option B, right? So option B is the correct answer to this problem. So this is the general result to this based on the option they gave to us. Remember, from here, every other thing you did here is a solution to this differential equation. So that we have to work towards the correct option given to us. So option B is our result.